Welcome back to our series of training presentations on the Adaptive Fisheries Assessment and Management Toolkit. In this session, we're going to talk about Step 5, which is performing your assessment methods using your actual data. So as a roadmap for this session, in the presentation I'll go a little bit about the importance of data visualization in the context of analysis. And then we'll actually go through a dashboard walkthrough so you can see what things will look like as you actually do these assessment techniques. And then as a breakout group activity, you'll actually use the AFAM Toolkit dashboard to perform data-limited methods for your site. Now, before we actually get into assessment techniques, I think it's important to talk about why data exploration and visualization is always a good first step. It's important to better understand your data and spot and remove any outliers. So always take a look at your data and make sure it makes sense. Understand if there are any common measurement errors. So for example, if a 0 gets added to a length measurement, you'll see a fish that's way too big. It also allows you to do quick back-of-the-envelope analysis. If you look at a simple length frequency histogram of your data, you can quickly see if there's a lot of immature fish in the catch. It can help you understand how different gear types affect the fishery. And really, this is the important first step before performing data-limited stock assessments. And within the AFAM Toolkit dashboard, the first thing you always do is visualize your data. So again, these are the methods included within AFAM, and there are modules within the AFAM Toolkit dashboard for doing each of these. Now, for each method, all of the calculations are done automatically, so you don't have to remember all of the equations that we saw in the previous presentation on performance indicators. But it's good to keep all of that in mind so that when you see the results, you can understand them a little bit better. So the AFAM Toolkit dashboard can be used for performing all of the assessment methods. It can be used online at the link provided, but can also be used offline. Now again, you need to install R on your computer and have some familiarity with that, so this is only recommended for advanced users. And again, the dashboard calculates all of your performance indicators automatically, just using some basic inputs. But of course, it's always important to double check everything. So we'll talk about the different modules grouped around the different types of data they fall under. So for length data, the first thing you do is enter life history information. So we talked a little bit earlier how there is a built-in life history database of 160 common species. So if yours happens to fall in there, it will automatically be calculated. But if not, you'll have to manually enter that life history information. The next step is to simply visualize the data and select a gear and year for your analysis. You could also select all gears or all years if you want to aggregate everything together. Then, after you visualize your data and make sure everything makes sense, you can turn to your assessment methods. Here's a screenshot of what the output of the fishing mortality from average length method looks like. You can see that the dashboard automatically calculates your performance indicator, which is F over M. In this case, it's 2.29, and it automatically compares it with your reference points that you defined earlier. Here you can see that our F over M is above our limit reference point of 2, so our result is red. So all of this is automatically calculated for you. It also provides a couple of the intermediate numbers, which might also be interesting, such as fishing mortality. Fishing mortality from catch curve is very similar. It also gives you an output table, but it also gives you a figure. You might remember from one of the previous presentations how catch curve is calculated. And so this basically just shows you how catch curve is calculated for your data. Again, this is all done automatically for you. And the output you receive is whether or not F over M is greater than or less than your target or limit reference point. In this case, our F over M is 1.63, and this is right between our target and our limit, and so we get a result of yellow. Spawning potential ratio is very similar. So again, you'll get an output table of your actual numbers. You also get some figures that show you how those numbers were calculated. In this particular case, the spawning potential ratio was calculated to be 0.24, which which is right between our target limit. So again, we get a result of yellow. Finally, for the length-based indicators, we get an output for the FROSI sustainability indicators. Here, we get numbers for the percent of fish that are mature, percent of fish that are optimal length, and the percent that are mega spawners. We also get some information on what the selectivity is and whether or not the spawning biomass is above our reference point. In this case, we can see we have 99% of our fish are mature and that our spawning biomass is above the reference point. This gives us a green result. Let's turn our attention to the catch and catch per unit effort outputs. So similar to the length data, we first simply visualize the data. So based on the data you upload, it will automatically create some time trends of how your data has been performing over time. We next select a reference period over which the catch and/or catch per unit effort values should be calculated. This time period should represent a desirable fishery condition. So essentially, we want to look historically and see which years were desirable fishery states, and we'll select those years using the options to the left. Then we'll see how our current catch or catch per unit effort compares to that reference period. Once we've done that, we can turn to our assessment methods. These give you a very simple output. So for trends in catch, it tells you how our change in landings is comparing to our reference point. We can see we've gone down about 58%, which is even below our limit reference point of going down 50%. This gives us an output of red. For catch per unit effort, we've gone down 15.7% from our reference period. This is right between our target and our limit, so we get a result of yellow. Finally, let's turn to our two indicators that are calculated from underwater visual survey data. As always, we simply visualize the data. So here we can see fish to unfished biomass ratio over time for our ecosystem. So again, what we want to do here is just to make sure everything looks sense. And in fact, we can see in this particular case that our limit reference point, which is shown in red, and our green reference point, which is shown in green, we can see we're above the green reference point for all years, which is a very good sign. So once we visualize the data, we enter a year for our analysis, which is usually the last year in our data set, and then simply turn to the assessment methods. These will be calculated for you. The first method is the biomass ratio. So this is an ecosystem biomass ratio of fish to unfished biomass across all species. You can see we have a number of 1.24, which is even above our target, so this gives us an output of green. Next, we look at the density ratio assessment, which is for this particular species, which is Caesiocunin. Here we get a density ratio of 1.3, which again is above our target, so again we get a green. So this has been a quick run through of the outputs of the dashboard. I think the best way to learn how to use this particular step is to really go through it using data from your own site. So first, I encourage you to use the AFAM guidance document to look through the instructions and references for step 5. Then you'll perform your assessments using the online toolkit dashboard. And finally, record your results in the worksheet. Thank you very much, and we look forward to having you back next time.